So, hello everyone and welcome back to another video. And so this is actually the second take of this video. There was a version that was already completely finished, edited and uploaded, but I've decided not to publish it. Instead I'm going to remake the video. And the video is about two GTX 970s. Here's one of them. The other one is right here. And these GTX 970s are from a friend. He gave those to me and told me basically, I can't really do anything with them. Look at them. Maybe you can do something. If you fix both, I want one of them back. If you fix just one, you can keep it. That's pretty much what he told me. And so I took the cards when I visited him. And so I tried to diagnose them, tried to figure out what is wrong with them. And just like every card that goes over my desk, I also want to do an overview. This is the PCB overview. I know I've said in the other video that the teardown is gonna be first and then there's a PCB overview, but these are special cases. You're getting the PCB overview first, and then also I'm gonna talk about what I already did to the cards. As you can see, I did some stuff. And the first card right here, you can see from the core that this is indeed a GTX 970. And this is a Palit Jetstream GTX 970. The PCB looks a lot like a reference card, but there are some differences. So the first one I noticed is that all the VRM chips are on the front, whereas the reference card has a layout like this, where half of them are on the front, the other half are on the back. For some reason, Palit decided to put all of them on the front. And then the VRM, which is still a 4-phase, just like the reference card. This is actually running a set of 35 amp power stages, which I'm gonna get into in a couple minutes, instead of discrete MOSFETs that the reference card is running. And then also the I/O is different. You get an DVI, 3 mini display ports and a mini HDMI, which is actually quite annoying because I do not have a single mini display port cable. I have a mini HDMI, but I'm not using that because the monitor I use only has one HDMI port and I have a full-sized HDMI cable in that, so I'm gonna have to use the DVI port. And I just don't like the DVI connector for putting something in, testing it, and pulling it back out. So this card is quite a bit inconvenient to work with, but okay, that's nitpicking. Let's get into the PCB and just try to ignore all the stuff that I obviously messed up on the PCB. I'm just gonna pretend that the card is completely fine. And let's get into the PCB. So we're gonna start with the VCore VRM with the VCore PWM controller. The VCore PWM controller is right here on the back. That is an NCP81174. I'm gonna get the datasheet on my smartphone real quick. So, nope, that's the wrong thing. My old smartphone is so slow. Here we have it, the datasheet. Okay. So, the NCP81174 is a 4-phase PWM controller. It goes from 200 kHz to 1 MHz, and the power stages on this card actually support 1 MHz, which makes me ask, what switching frequency are these running? Because they could run 1 MHz. I don't think they are, but they could. And apart from that, it's a pretty standard PWM controller. The other card is using the exact same one, though that it is implemented slightly differently. So the NCP81174 can operate in 2, 3, or 4-phase operation. Here it is 4 phases. And so that's pretty much everything interesting about it. It's a pretty basic PWM controller. And then going back to the front, we have these before mentioned power stages. These power stages are, I don't know if you can read it. These are NCP5369s, and these also come with a datasheet. I've already said these are 35 amp power stages. And yeah. Integrated driver and MOSFET. Yeah, okay, so these are actually not really power stages, because on semiconductor calls them integrated driver and MOSFET. So these are what you would call the RMOSs. So you have your high side, your low side, and your driver IC in one package. Though I've read into the datasheet, and these can raise a thermal flag, which makes them kind of a power stage, because as far as I know, the RMOSs do not have any kind of temperature monitoring. These do not have a temp sensor, but these can tell you, hey, I'm overheating, and then they turn themselves off. So I would call these very basic power stages, because as far as I know, the RMOSs do not have the capability to raise a thermal flag. I could be completely wrong about this, I don't know. It doesn't really make that much of a difference. Have they actually listed, yeah, so like 35 amp power rating? Do they have any RDS on listed? I don't think they have. Yeah, it doesn't look like that before this video gets too long. Yeah, so, and then that's pretty much everything for VCore. You only have, I mean, everything's in one chip, so pretty simple. And then for the memory VRM, we have it right here. The memory controller is actually very interesting, because that one was very difficult to get a datasheet for. So I'm gonna get to this last. So first, let's look at the MOSFETs. These are from Power. These are SM7302 dual end fets. I don't know if you can. Yeah, you should see that. Only that it's upside down. Yeah, SM7302s. These are dual end fets. We are actually going to see very similar ones for VCore on the other card. So these are, so the height side is rated for 48 amps. Is that the continuous drain current? Yes, it is, but at TK is 25 degrees. So yeah, let's just look at the RDS on. So the RDS on is rated on the high side 7 milliohms at 10 volts gate to source voltage. These are probably running 12 volts. Wouldn't be that great of a choice to run them on 5, so I'm guessing they run 12 volts, so that will be less than 7 milliohms. The low side on them is rated for 4 milliohms at 10 volts gate to source voltage, so that's also going to be slightly lower for 12 volts, and the low side, yeah, let's look at the continuous drain current 40 ambient. So channel 1, the high side, continuous drain current T ambient 70 degrees is 9.5 amps, and the low side is 16 amps. That's a pretty big reduction from the TK's 25 degree rating, but these are only powering memory, and you've got 2 of them, so that's more than enough. So let's get on to the PWM controller for VCore. The other card is also using the same one, and this one was very interesting. Sadly, you can't see the markings really. It says on there 081JA2K. If you put that into Google, you get some kind of address in the United States and nothing else. So that is actually not the name of the controller. It is a code that is used to identify what controller this is. And thanks to a helpful human being on Reddit, I did find out what controller this is. So this is not an unsemiconductor controller as I first suspected, because like these are on semiconductor, the other controllers on semiconductor. Nvidia uses on semiconductor a lot for their reference cards. So I was thinking this is probably also on semiconductor, and I did find a chip, the NCP5383, I think, that was very similar. Actually, I think it even had the same pinout. But this is not it. This is, as it turns out, a Richtech RT8809BZQW. And yeah, so someone on Reddit linked me to a Russian page where someone listed all the codes. So 08 is actually the identifier for this. And this leads to the RT8809 family, and there are 4 versions of it. And I have the 08 version. There's also 08 equal, 07 equal, and 07. So I have the 08. And yeah, so this is a dual phase PWM controller. As you can see, there is no really, I'm not seeing any switching frequencies listed over here, but like, okay, that's not really that important. It's a memory VRM. The important thing is actually the pinout. I needed the pinout because I was expecting the controllers on both of these cards to have a problem. They might actually have. Actually, I don't think on this card. On the other card it might, because the other card is very weird, and I haven't actually done anything yet to it, whereas I clearly have done something to this one. Yeah, but I'm going over what I did after I look at the PCB of the other card. So that's for the Palit one. Let's take a look at the other card. So this is very clearly not a reference PCB. And if you've looked at some PCBs, you will see these inductors give it away. This is an MSI card. This is the GTX 970 MSI Armor, actually. So the PCB of this is almost completely identical to the Gaming 4G, which was the normal red cooler dual fan card you have. And the heatsink this one's come with is like, it's black with some blue accents and really small thin stack. So this is like the normal Armor cards you see from MSI. You get a nice PCB, but the cooler is really not that great. So yeah. And this PCB is almost identical to the Gaming 4G, which would today the MSI calls them Gaming X. Back then it was Gaming 4G. There are some very slight differences. First, this card does not have an LED power connector because there's no LED in the heatsink of this card, and this power connector over here is a 6-pin, and as you can see there's space for an 8-pin because the other card is running an 8-pin here. So yeah, I guess this card just has a lower power limit, which won't stop us if I repair this. But yeah, so that's the differences that I can see. And so let's get into the VRMs. So back here we have the same PWM controller that we looked at on the Palit card, the same NCP. I forgot the number. Was it 81174? Okay, yeah. So that's the NCP 81174. And so we said that that controller is a 4-phase controller. Why do we have 6 inductors and 6 dual end fets on this card? This is a doubled 3-phase. So this is actually a card where they took a 3-phase and doubled it. So this is running in 3-phase mode. And then it's going into these ICs over here. So there are 3 square ones and 3 non-square ones. And these are, I'm gonna look up the datasheet again. So we're gonna start with the non-square ones because these are the drivers. If my smartphone loads the PDF. These should be, please load. Yeah. So these are NCP 81061s. These are just a dual drivers. So these are two MOSFET drivers in one package. And these drive the 6 dual end fets that we have here. So one of these drives 2 dual end fets. And yeah, that's pretty much it. It's a dual driver. And then we have these square ICs, which, as you might have guessed already, are doublers. And these are NCP 81162s. And these are actually quite interesting because these are not dumb doublers that just send half of the pulses to one phase and then half of the other half to the other. These actually have some current balancing. So I don't think it's anything fancy because these chips are not, they're not really that complex looking. And I also don't want to waste too much time in the video talking about these, so I didn't really read into the datasheet. But the datasheet does state that these do have current balancing capabilities. It's probably more basic than really sophisticated, but you do have current balancing on these. So these can current balance the two phases that they're doubling into, which is nice to see. So these are not completely dumb doublers. So this 6 phase is actually, yeah, it's not just a dumb doubled 3 phases. It's actually capable of current balancing all of its 6 phases as 6 phases, and not just like every 2 phases as 1. So yeah, and then let's go for the dual end fets. These are, as I've already said, very similar to the VMem dual end fets we saw on the other card. And these are also from Signal Power, use the same package, but these are not SM7302s, these are SM7320s. And the difference is just that these are rated for more current and they have lower RDS on. So the high side has 5.2 milliohms RDS on at 10 volts gate to source, so it's probably 4.95-ish at 12 volts. The low side on them has 1.8 milliohms at 10 volts gate to source voltage, so at 12 volts that's probably 1.6, 1.7-ish, which is actually pretty good, considering you have 6 of these. And yeah, so for the current ratings, the continuous drain current at T ambient 70 degrees is 13 amps for the high side and 24 amps for the low side. And because we want to make sure, so we had a 24 amps times 6, that's 144 amps that these MOSFETs, or these dual end fets, can deliver at 70 degrees ambient temperature, which is probably a lot higher than these are realistically gonna see. So yeah, the VRM is like, these are not some fancy DRMOS or power stages even, but like the doublers used on this VRM are actually quite decent, and from the current rating and the RDS on these dual end fets are also not all that bad. So this VRM is actually pretty okay, and this VRM is also still in one piece, other than the other card. And yeah, so the memory VRM on this card is pretty unspectacular. So we have the same mystical controller. On this one you can see the markings really good actually. It's another 2-phase, but using discrete MOSFETs from Nyko Semiconductor here. I didn't bother looking these up actually, so yeah, it's a memory VRM, like, don't really care. I only looked the other ones up because they're so similar to these. So that's pretty much it for the PCB. No, I forgot to mention what memory these are running. Both of these run Hynix MFR, and yeah, that's it for the memory. And yeah, actually one interesting thing that I can actually got the camera so close you can't see both of them completely. So one interesting thing about the PCBs is that you see these two here. These are input filtering inductors. These smooth out any 12 volt transient spikes that you might get from the card to the power supply. The Palit card doesn't have them. There's no there's no input filtering on this, not even on PCIe. There is, you can see here, there's shunts. There's one shunt over there, there's another shunt over there, and the third one is on the back, just as this card has. And yeah, but there's no input filtering inductors. So what's gonna happen is if the card is under a really, really nasty transient, that transient is going to translate to the power supply because the inductors are not smoothing it out. So if the 12 volts power plane on this card sees a really nasty transient, like a really, really nasty current spike, that's going to translate to the power supply. And if your power supply is a cheap unit, that could potentially throw your voltages out of whack and cause the system to crash if the voltage goes out of spec too much. And yeah, so that's not that great. And yeah, usually, like, there was one 1080 Ti, I think, from Zotac, where they just genuinely ran out of space for input filtering inductors. So I can understand it there, but here, that's just a cost-saving measure. Because you can see, so instead of inductors, they are using what is labeled as R on the PCB, so a resistor, basically. There's one here. These two are hooked up to the 6 pins, and then this one here is hooked up to PCIe. And now we can get into what I did to try and repair these, because you can see I did something to them. This one here was burned out. So these resistors are just 0 ohm resistors. They are basically shorts. They just connect where the inductor would be. And this one here was not at 0 ohms. It was at infinite ohms. So this was burnt out. So I took this bodge wire right here, that's 18 gauge, I think. I stole it from a power supply, and I just bridged this input resistor, so to say. Being me, I was too lazy or too forgetting to not check why this actually burnt out, because fuses sometimes just fail. Without anything being wrong on the card, but if a resistor burns out, like, you can use resistors as fuses, but these resistors are pretty big, so these are burning out when you have a big problem. And that big problem you can already kind of see. There's a phase missing. That big problem was this this NCP5369 being shorted all over the place. So, and this resistor connects to that phase. So actually how the phase layout is. One 6-pin, I think the left 6-pin actually, I'm not sure which one is which. One of the 6-pin goes through this resistor and then to those two upper phases. This third phase is actually connected to PCIe, and then the lower phase and memory is connected to the other 6-pin over this resistor. And this power stage right here died. So it shorted 12 volts to VCore. So when I bridged this, so before I did anything to the card, you would turn it on and you would get no power on memory or VCore. The core would stay cold. Nothing would happen. Like, the BIOS would initialize, B2 postcode would be passed, but the card just wouldn't turn on, so your VGA light stays on, you get no picture. Actually, the exact same thing is on the other card, but that card has a different problem, just the same symptoms. So yeah, after I bridged this resistor right here with that wire, I turned the card on and the system immediately tripped over current protection, and I actually didn't notice. I was just like, shouldn't it be turning on? Because I actually missed it tripping over current protection because my attention was somewhere else when I pressed the power button. I pressed it again and was like, oh, okay, we're hitting our current protection because 12 volts is shorted to VCore. The GPU got a short of 12 volts, or like higher than what it should be because there's still an inductor. So the voltage is rising, it's not immediately going to 12 volts. So, I then thought, okay, yeah, we have a short from 12 volts to VCore, and I was stupid enough not to check this after bridging this resistor. So, me not having a hot air rework station, I just thought, okay, so this power stage is out. This one right here. What am I gonna do? I'm gonna remove the inductor. So I removed the inductor. It is right here. And how I removed it is I tried to solder it, to desolder it first. That didn't work. So I took pliers, went outside and just ripped it off, and that actually worked. And after that, the card would now turn on again, but like, okay, the card would not trip over current protection instantly because the short is gone. And you could already see I measured this side. Yeah, that was 12 volts, and this side was still 0 volts. Memory was also still 0 volts. So there's still a problem. And that is where that white wire comes in. And this white wire represents the worst, most stupid, most brain-dead engineering decision I've ever made. Even worse than bridging this and not checking for shorts. This wire was connecting the literal gates of the MOSFETs to this static 5 volts LDO right here. I completely forgot how MOSFETs work. Like, the gate is where you turn the MOSFET on and off, where you close and open it. If you put the gate to a static 5 volts, it's going to be on all the time, which makes all of these essentially also a short, just like this dead one. Luckily, the card tripped over current protection. Actually, not the entire system, just this LDO shut down. And yeah. So I completely forgot how MOSFETs work. Because, like, the thing is, the gates are not getting power. Like, there's no gate drive on this card. And that is actually because this dead power stage right here is shorting gate drive to ground. So whatever's powering the gates is detecting that, it's tripping over current protection, and now the MOSFETs are not getting powered. And these are also not getting powered because maybe there's some pulling low pulling going on, like something shutting down the other VRM too. Maybe it's somehow connected. I don't really know. The fact is that this VRM is also still shut down. So now I had to remove this, and you can see it's already looking like I did something to it. I tried the same approach. I took pliers and thought like, hey, this is quite a large chip. Maybe I can just, nope, not coming off. So to fix this card, I'm gonna have to get a hot air rework station. I could maybe ask a friend of the RC model plane club that my dad is in, because one of them has a hot air rework station, but that's like a really cheap one, and I could just buy one for myself because the fix for the other card is likely also involving desoldering of ICs. Or maybe not, actually, I don't know. So yeah, I could certainly use a hot air station. I was just not planning on buying one. But if I want to repair this card, or like have a chance at repairing this card, I'm going to need a hot air rework station. And it's gonna be a really cheap, crappy one because I don't have the money for a proper one. So yeah, I'm gonna get a cheap and crappy one if I get one. And then I'm going to complain that it's cheap and crappy. But like, yeah, having a crappy hot air station is better than having no hot air station, and having this card is basically a doorstop, because with this short from gate drive to ground, there's basically you can only e-power this. And yeah, I don't want to e-power this. I do have a GTX 470 VRM that could e-power this, but like, nah, not worth it. I would replace this VRM with one that's on par or worse, and that's not worth it. So I'm not e-powering this. So yeah, I'm probably gonna ask a friend of my dad's, or buy myself an own hot air rework station, or I'm just gonna ask a repair shop to remove this. One of the three. But yeah, so if I remove this, the short from gate drive to ground should be gone. And if I'm lucky, the MOSFETs will get their gate drive again, and the card will work. Admittedly, there's going to be one of the 4 phases missing, but since these are 35 amps, 35 amp power stages, and this is a GTX 970, like in terms of current throughput, this is gonna be weaker than the other card because, well, you ain't got a lot of phases left. But it's gonna run, and I know from, oh no, I forgot the name. There's this really cool YouTube channel, just exploded with subscribers, like a British-looking dude, I think, running a repair shop, and he's repairing computers. And he had a GTX 960 that was a reference PCB, and these are running a really crappy 2-phase VRM with discrete MOSFETs, and one of the phases blew up, and he just removed it and went thermac on one phase on that card. So yeah, if a 960 can run on one phase of crappy discrete MOSFETs, I think a 970 can run on 3 pretty nice power stages. I don't think this is gonna do any extreme overclocking, but like, it's gonna run. It's gonna run. So that's pretty much a repair for this card. I'm going to remove this wire. I really can't but laugh at myself for this. How could I think that hooking a static 5 volts to the gates of the MOSFETs would, like, fix it? I completely forgot how a MOSFET works. Like, if you think about it, you have your drain where 12 volts comes in, you have your source where your VCore comes out, or like VMem comes out, where the output goes to the inductor, and then you have a low side where the output goes back into the inductor and loops around. Then you only have the gates left, so where's it gonna get control from? Well, from the gate. And I just hooked up static 5 volts to the gates. So, yeah. This is kind of reminding me of when Bullzoid killed that 980 Ti, where he had also a dead power stage, but that one was a really, really bad short. So the board was shorted, and he thought, well, I'm just gonna, because it was just at the edge, he thought, okay, I'm just gonna cut out that part of the PCB, and then the short is gone. The short was gone. The only thing is, his card was gone too, because what happened is there was a feedback line for VMem going through that part of the PCB, and when he cut it, the feedback line was gone. So when he turned the card on, VMem put out 3.3 volts. And yeah, that just toasted all the memory and the integrated memory controller of the core. So that's kinda on that level, but I think mine's more stupid because he forgot to check something. I forgot to check something here, and here I had complete disregard for the basic theory of how a MOSFET works. So yeah, laugh at me for this. So let's get to the second card. This one is a lot harder to figure out. So there's no shorts on this, none that I can see. I actually haven't checked PEX yet, but the PEX is gonna be okay because this card has the same problem where VMem and VCore are dead. So there's the MOSFETs are not turning on, the MOSFETs are getting 12 volts. I checked already, 12 volts is getting everywhere. But the MOSFETs are just not turning on, and gate drive is also dead. And yeah, I couldn't find any MOSFETs that are dead. So I think this card is just straight up missing gate drive, and that everything else is okay. And so what I'm gonna do later today is check the drivers, and maybe also the doublers on this, and the PWM controller and whatnot. Because this 5 volt 80 over here, that works. That should be the PEX regulator. And yeah, so I don't know yet what the problem on this card is actually. It's just like I keep looking for problems and I can't find any. The card is just not running. It refuses to run, and that's kind of frustrating. So both VCore and VMem are getting 12 volts, but apparently there's no power going to the gates, so there's no gate drive on both rails again. So maybe, so my theory is, and what I'm hoping for is actually just that the drivers are not getting power, or the doublers are not getting power. That's my hope, because then I can just take any 12 or 5 volt input, 5 or 12 volt source, run a board wire, hook it up, and it's gonna run again. What it probably is one of the drivers or doublers is dead, it's somehow shorted, or it's just not running anymore, and the VRM detects that fault and shuts down itself and VMem, and possibly also PEX. I didn't check PEX yet. And yeah, that's also gonna require hot air rework. So yeah, and a really bad thing would be if one of the MOSFETs is indeed shorted, because a problem with with the dual end fets on VCore is you can see the solar bumps right here on the left side, but on the right side you pretty much can't see them, and you also can't get in there really well with a multimeter probe. So yeah, so I did get some connections on this, like because 12 volts is going in on that side on this, I think. Actually, I forgot the pinout. It was really late in the afternoon yesterday, but I checked this side. That's hard to get to. But like, it could still be that one of the dual end fets is dead, which would be pretty bad, really bad, because that too is gonna require hot air rework. But I'm gonna, yeah, I just hope that power is missing for the drivers, because that's an easy fix. It's probably not. It's probably one of the drivers probably went out. And that's one of the better things that I can hope for. Like, there could also just be a random short somewhere on the board, and then like at that point it's also just like a e-power or trash bin card. And it's just like, yeah, it's a 970, and then the only VRM I have to e-power something is a GTX 470 VRM. That one's good for like VMem and VDDCI, not for VCore, except for maybe on a super low power card. So, yeah, that's kind of it. And, yeah, so this card is probably the more fixable, actually. So if I find the problem, it's probably easier to solve, because I have a, so I think it's more likely that the core and the memory on this card is still alive. Because the other card, as I've said, I gave it 12 volts to VCore more than one time. And also this being burnt out, like again, that's a pretty big resistor. That being burnt out means there had to be a shit ton of current being pulled through there when that driver when that MOSFET or power stage or whatever died. The core might have gotten 2 volts, like 2 volts is enough, your core's dead. Memory can actually, and IMCs, at least on Fermi, can actually survive 2.1 volts, because there was a volt mod that I wired up wrong and gave the memory and the IMC 2.1 volts, and that actually kept working. But the core getting 2 volts, that's like dead. And yeah, so 12 volts was shorted to VCore once when that thing died, twice when I bridged this and got OCP, and one more time, probably when I, or like it was shorted to VMem and then the IMC, when I hooked up static 5 volts to the gates and like forced the MOSFETs to stay open. But since that's still shorted to ground, that might have tripped OCP pretty fast and then just saved the card. So this core got a lot of shots of 12 volts. And yeah, so it's pretty much, it reaches 2 volts for like a couple milliseconds, and this core is turned into sand. Since there's inductors between the shorts I created and the core, we don't know where the voltage was. It was certainly not at 12 volts, or like if it was shorted for long enough and not shut down, it might have been at 12 volts, but like usually that's not. And yeah, so this core and probably also the memory and the IMC are probably, not probably, but they might be very, very dead. I hope not, because this little tiny PCB, I just like it. It looks kind of cute, I think. Like a GTX 970, that's about as fast as a 780, and 780s have like freakishly giant PCBs if you want a good one. And this one, I wouldn't really say this is a particularly good one, but like it's certainly upgraded from the reference PCB. So yeah, I would really like to have this card working, because like, yeah, this PCB is looking kind of nice. If I manage to fix both of them, this is probably the one that's going to my friend, because like well, the main reason is this is not going to fit a water block, because it's going to collide here and probably also here. And yeah, that's pretty much it. And yeah, I don't know. I don't know how moddable this is compared to the other one. Probably the same. Yeah, but this is, if I fix both, this is probably the one that's going to my friend, just because I can't fit my water block on here. And he's like, he does have a water block that fits GPUs, but I don't think he's gonna try to run this on water. He's maybe going to put a Morpheus heatsink on it, which that might be a problem with. I don't know if the Morpheus can fit the smaller hole spacing. It will fit the bigger one, but this might be a problem. But yeah, the Morpheus heat, it's a 970, that should be enough. And yeah, so that's actually pretty much it. That's pretty much it for the cards. So the video was already pretty long when I first made it. Now it's even longer because I included more info. We are coming. So the recording is at 41 minutes. I don't know how much I'm gonna be cutting from the beginning when I did synchronization and all that stuff. So I'm probably just gonna end it here. So these are the two GTX 970s that I got to maybe repair. And yeah, so this is what the PCBs look like. This is what I tried, messed up, and yeah. So thank you for watching, hope you enjoyed, and until we see each other next time, goodbye.